That's called an irrational number, correct? Okay. The process that we're going to go through is going to remove all irrational values from denominators. And what it will do is actually make every denominator rational. And that's why it's called rationalizing denominators. Okay. There's just a basic rule that we go by. And in my opinion, I think the rule is designed because in future applications, it's going to be easier to work with if there are no radicals in denominators. But basically the rule says you never write an answer with a radical in the denominator. It's just a general rule that all across mathematics we abide by. Okay? And usually people ask, well, why? And I said, like I said, usually the argument is because it makes mathematics later on a little bit easier. But there are also times where leaving the radical on the bottom might make mathematics down the road easier. Okay? So it's just a general procedure that we abide by. It's much like when we talk about 2/4. I won't write 2/4 as an answer, right? I always reduce it to 1/2, correct? So it's part of that simplifying kind of structure that we, as mathematicians, all agree that we're going to abide by. Okay. So what we do here, and it's a very straightforward procedure. I'll start with some easy ones here. If I start with 2 radical, let's just say 3 on the bottom. Okay. 2 radical 3. The approach for doing this, the steps that we go through, is to recognize the radical component in the denominator. Okay, because that's the issue. That's what we want to get rid of, so we have to target that thing. So in our case, it's radical 3, right? Sometimes that, and we'll see some examples, maybe it was like radical 28. Well, radical 28 can be simplified. It might be better for us in that situation to simplify this radical first, okay? So you might, and you'll have options. You might want to recognize what the radical component is in the denominator, and then either simplify it right away or jump to this next step. And this next step is to multiply the bottom by that radical component. So what I'm going to do is I'm going to multiply radical 3 by radical 3. Okay? Now, if all I do is multiply the denominator, and I don't do anything to the numerator, I change 2 radical 3 into a completely different number, or 2 divided by radical 3 into a completely different number. Let me show you with Desmos here real quick. If I did something so we start with 2 divided by square root of 3, okay? And I multiply, the only way I can just multiply the denominator, so let me write, so that's that answer right there, okay? When we rationalize the denominator, we will not change this number. It will always be 1.154. It'll look different than that, but the decimal will always be 1.154. Does that make sense? Okay? Well, if I just multiply the bottom by radical 3, what's radical 3 times radical 3? Not 1. Think about how, remember, if we're multiplying radicals, we multiply the numbers on the outside, and then we multiply the numbers on the inside, so it would be 9, which is going to reduce then to 3. Okay, so if I did just this, okay, and nothing to the top, what I'd be left with is 2/3. Is 2/3 different than that number right there? Yeah. So I can't just multiply the bottom by radical 3, okay? Because I don't want to change the value. I don't want to change the value of 2 divided by radical 3. So what number can I multiply? So if I gave you, you're thinking of a number in your mind right now. Don't tell me. I already know. If you were to multiply it by a number so that it doesn't change, what would that number you use to multiply be? 1. So I don't want to change 2 over radical 3. So I need to multiply it by 1. But I know that I got to use this radical 3. So what would the numerator be so that this red number is 1? Close. That would give me 2 though. Does it have to be radical 3? Huh? So again?
I thought you would make the, since you can't have radical as the denominator, I thought it would be the 2 radical 3, then below it is the denominator.
Yes, that will be the result. That will be the final answer.
Oh.
But if I started with this, so I start with 2 over radical 3, okay? I recognize that thing right there. I don't like that radical 3 in the bottom. So that's what I multiply by over here. But I don't want to change this quantity of 2 divided by radical 3. So I can't just multiply by 1 over radical 3. I have to multiply by radical 3 over radical 3 because something divided by itself is always what? That red number is the number 1. That's the number 1, right? It's just, we don't ever write 1 that way, but that is simply 1. Something divided by itself is 1. So we call this a convenient version of 1. Okay? And it's convenient because of what happens. If I multiply, okay, remember multiplying radicals, multiply the numbers that are on the outside. So 2 and 1 are on the outside here. They multiply together. And then there's no number here. And there's a number on the inside here, so they'll multiply together and give me 3, right? Does that make sense, everybody? 2 radical 3 there? Okay. On the bottom, you guys told me that, well, that was radical 9, which is 3, right? So when I multiply a radical by itself, I'm always left with just the radicand that was underneath one of those radicals. And now look at my denominator. What kind of number is 3? It is prime, but is it irrational or is it rational? It's rational. It terminates, right? Okay, it can be written as a fraction. Okay, so now we've ultimately removed this irrational number from the denominator, and it's become rational. Irrational has become rational, so that's called rationalizing a denominator. Okay, so now if we look at typing this in, do we see that we changed the way it looked, but we didn't change the overall value of it? And that's what we refer to as rationalize a denominator. Okay. There are some patterns to this that you can recognize, or that we will recognize. I think maybe after we do a couple of them, maybe we'll talk about that pattern, or you'll see that pattern. Let's do 5 divided by radical 6. Yes. Yes. What do we not like about that? We don't like the radical 6. So we're going to take that radical 6 and multiply it here. And what do I multiply on top? Radical 6 again. Okay? So it's always, so whatever that denominator was, it's always you're going to multiply the top by it and you're going to multiply the bottom by it. 5 radical 6 over 6, and you're done. Okay. The one thing that both these examples have shown is that when I'm done, in that first and that red one, the 2 and the 3 on the top and the bottom, they are what we refer to as relatively prime to one another.
Okay, so I'm putting things together, so this is wrong, but so like the denominator, is it always going to be after you do that radical? you know how there's sixes on both of those radicals, and then you come out with 5 radical 6 on the 6. So will the denominator always like?
So you're seeing the pattern. Is this denominator always going to go up to the top?
Yes.
And is this new denominator at the end in our answer just going to be the number that was underneath here?
Yes.
Now Yes.
You want to say it that way so then everyone can know how to actually do it.
Yes. And we might see some examples that we have to maybe finagle things because of simplification processes that go on in a little bit here. It might not directly look that way. And the reason for that is what I was trying to get to is if I look at that 2 and that 3, let's talk about the factors of 2 and the factors of 3. Okay? And we're not going to count because every number has a factor of 1. Every number is divisible by 1. So the factors of 2 are 2. And the factors of 3 are 3. Okay? So those two things do not share any factors. Okay? They're said to be relatively prime to one another, meaning they don't share anything that evenly divides both of them. Okay? If I look at 5 and 6, the factors of 6 are 2 and 3. Okay? And 6. And the factors of 5 are 5. Okay? So those are the values that divide the, excluding 1. Okay? But are there any factors in the factor for 5 that are shared by the factors of 2 and 3 and 6? No. So what that means to me, that these are what we say relatively prime. So it means that these two numbers here could not be reduced any further. Okay? Let's do this question here. And this might change a little bit, Maya, what you are recognizing with your final answer. So let's go. Let's just go 12 over radical 6. 12 over radical 6. So what am I going to multiply the bottom by? Radical 6. And I'll multiply the top by radical 6, right? So it gives me 12 radical 6 over 6. Which matches up to exactly what you said was, I fell down, was that you're going to take, that you're going to take that number and you're going to put it up in the numerator and get 12 radical 6. And then the denominator is just going to become the 6 that was underneath the radical. So you can see that pattern. Now, go ahead.
Okay, so since the denominator you can break down with the numerator that's not underneath the radical, we can break it down that way?
Yes. So that number right there and that number right there, they share factors, right? They share a factor of 6. They're both divisible by 6. So I'm going to do that. What's 12 divided by 6? 2. And then 6 divided by 6 is 1. And we usually don't write divided by 1, right? We just write 2 radical 6 as our final answer. Okay? But one thing to pay attention to here is that when we do simplification, that number that's in the radical, it's kind of locked away in there. You can't do anything with that radical 6. Okay? You can't simplify. Because some people say, well, 6 goes into 12, but it also goes in that 6, so let's write this as 2 radical 1. You can't do that. And that radical 6 is stuck. Remember, it's a symbol for another number. So let's see, maybe.
Is it like what is it,
Common factors?
No. When you, like variables, like if there's an A and an A, you add those together, what is it? I can't remember what that's called.
Like terms.
Yeah.
Yes. Yep.
So like if there's another radical, that's when you do that as radical or no?
No. So what we're saying here, so when I have 12 radical 6, so radical 6 as a decimal right, it's that number there, right? Okay. So then when we had 12 up there with it first, right? So 12, I'm going to write 12 as 2 times 2 times 3. That's the prime factorization of 12. We see that it is 12, right? Okay. I'm going to take that number right there and paste it there. Okay, so that is 12 times radical 6 right now. Is everybody okay with that? Okay. On the bottom of the fraction, we had we had 6, right? And 6 is 2 times 3, correct? So do we see here, if we do it that way, that, and the reason why we divided by 6 was that this 2 right here and that 2 right there, what's 2 divided by 2? 1, so they cancel out, right? That 3 right there and that 3 right there, they cancel each other out, right? Okay, so we're left with nothing on the bottom, but we're left with 2 on top and that number right there, which we said was radical 6, right? So 2 radical 6 ends up being our answer, which was the same thing then as it was 12 divided by radical 6. That's what we started with, and that's what we get to. Okay? But the reason we can't, hopefully we see here, the reason we can't cancel that 6 right there with that 6 right there is because that's really not a 6. That symbol radical 6 is standing for that 2.24 number, which is not sharing factors with that 6. Let's do one like 3 radical 2, but then we'll have a radical 3 in the bottom. So here we got radicals in the bottom, radicals in the top. Okay? So which doesn't, following your pattern would still work, but if following that pattern doesn't get me the way that I would normally write my final answer. Okay? So using Maya's pattern, she basically said, well, doesn't that radical 3 just go to the top? And then the bottom stays 3, right? That would be your pattern, correct? That's what we did here. We took that radical 6, put it up top, and then the number that was under the radical became our new denominator. Okay? That's exactly the same thing that would happen if we went radical 3 here and radical 3 up top. We would have 3 radical 2, just doing the implied multiplication, not really multiplying anything, just writing them right next to each other. And on the bottom, you'd have 3, right? That's exactly your pattern. Okay? But at this juncture, we'll never write an answer as 3 radical 2 radical 3. Okay? What is happening between these numbers up here? What operation? Multiplication. And that radical 3 has got a, I like to look at it right here instead. Okay, but so when I do multiplication of radicals, I do number outside times number outside, right? What's 3 times 1? 3. And now I do number inside times number inside. And then on the bottom, that becomes 3. And the 3's cancel out, and you're left with just radical 6. Let's do one where you've got some options on your approach. Let's go 3 over radical 8. What can you tell me about radical 8? You can break it down further, okay? Now, no matter what, you're eventually going to have to deal with that radical 8 and simplify it. If you want to do that first, you can. Or if you want to do it second, you can. It's up to you. And we'll go both ways. Okay, so first way here, let's not simplify right away. So if I'm not going to simplify right away, what do I need to multiply by? Radical 8 over radical 8. And that's going to give you on the top 3 radical 8. And on the bottom, it's going to give you just 8, right? Okay? It's a better answer because there's no radical on the bottom, but it's not a simplified answer because that radical 8 needs to be broken down. Radical 8, you get 2 and, right? So you can get a group of 2's to come out of the radical. You got a group of 2's that stay under the radical, or I guess an individual 2 that stays under the radical. And then we had this 3 that was already out in front, right? And that's all over 8. So what's 3 times 2 on the outside then? 6. And you could be a person that says, well, why did you do that? Or you can do it and just kind of blindly keep going. I don't know that it makes sense for me to actually multiply that 3 and that 2 right here. Because what do you see the relationship between the 2 and the 8? That's the common factor there, isn't it? Okay. But some people will multiply that out right away and get down to 6 over 8 and then realize, okay, well, 6 and 8, do they share that 2? So a 2 can go into 6 over 4. 3 radical 2 over 4. And that's your final answer. And how do I judge? And this is something that I hope is one of the things that mainly one of the byproducts that I hope that I kind of get students to realize when they're in a math class, and a byproduct of all the classes I teach, not necessarily that, because I know you're not, I've been in your seats, okay? I've been in many of algebra classes, many of geometry classes, calculus classes where you're sitting there and the assumption is once we see it, we've learned it. Because that's the way math works, right? In order for us to be good at the next section, we have to have the assumption that we mastered this section, right? And not everybody does that. And not everybody memorizes exactly every single thing that they've come across. But hopefully we have maybe tools that help us, if we forget something, to see if something we're trying might work. So let's say we get on a test or quiz, and I'm not 100% sure that I could do this right there. We'll talk about it. So maybe I don't know that I could have gone from 3 divided by square root of 8, what I started with, and rewrite it this way. So I write it as 3, so I type in my calculator 3 square root of 8 divided by then 8. And what does this recognition of that decimal and that decimal tell me? They're the same. So what's that tell me about my rule that I implied there, or I employed? It's allowed to do it, right? Does that kind of make sense? It was legal. That was the approach that we're supposed to go by. Okay? So then I get to the point where I say, okay, well, was it okay to take this factor of 2 out? And I'm going to do something erroneous here. Because some people will see, and we talked about this earlier, that there's a 2 in that number right there, right? And there's a 2 in that number right there, and there's a 2 in that number right there, right? So some people will say, I'm going to take a 2 out of all 3 of those things. Well, if that's allowable, then when I type that into my calculator, once I take that 2 out of everything, I should still get this number right here, right? So if I take that 2 out, I would have 3 square root of 1 over 4. And do I get that number right there? No. So it tells me then that 2 that I tried to take out of here wasn't allowed to be done. Okay? And if you're a person that says, well, I'm thinking that I could take a 2 out of it, but that didn't work. Can I take a 2 out of just these 2? Or can I take a 2 out of just these 2? Well, try it. Just take a 2 out of these 2. See if I go 6 square root of 1 divided by 4. Just taking a 2 out of the radical and the 8. Well, that doesn't give me my 1.06 that I started with. So that's not allowed. What if I take a 2 out of just these two? So give me 3 square root of 2 over 4. And I generate the same decimal, so that must have been the cancellation that could occur. Does that kind of make sense? Okay. So you can use your technology to help kind of spark a rule that maybe you've forgotten. Okay. So that was simplifying, not simplifying first. Let's see if simplifying first might make things easier. Yeah. If we take our 3 over radical 8 and simplify that first. So we already know radical 8 turns into 2 radical 2. So we would have done that first. Now what is the radical component on the bottom? What's the radical part on the bottom that's throwing us a fit here? It's the radical 2, right? And it's only it has nothing to do with that's already a rational number. So you don't have to, you can, but you don't have to do anything with that 2. Okay, it's the radical 2 that's giving us issues. So I'm going to multiply by, in this case, radical 2 over radical 2. So what's that going to turn the top into? 3 radical 2. And on the bottom, what's radical 2 times radical 2? Radical 4, which changes to 2. So you got this 2 times that 2, which gives you your 4, which is the exact same thing we had right there, right? So you can simplify first, or you can simplify second. I'm a fan of actually simplifying in all my problems. I like to simplify as late in the problem as possible. And it's just through experience that I know sometimes the multiplication that we have to do in like rationalizing might take care of the simplifying for us. Okay? It's just, after you see enough of them, you'll realize, well, I'm going to simplify later in the problem because it just makes things a little bit, in regards to work, a little bit less. Does this kind of make sense on how to do this? All right, I'm going to give you guys a little bit of time here. I'm going to open up an assignment so that you can do a little bit of this for homework.